Okay, so let's go ahead and write the source code for a while loop example to explain again how a while loop construct is put together. Now remember, I mentioned 3 items that you need for a successful while loop construct. One is the loop priming, second is the actual loop condition, and third, within the loop body, you need to have some sort of a loop control. So 3 items: priming, condition, and control. So I'm going to break down my program here into my declaration. Again, typical for C, C++ procedure as to what you might find in it. Maybe some sort of an assignment. Okay, and these are comments. I'm just breaking down what I need to do. And we're going to do our loop right here. Okay. So within the declaration, we will also have we're going to have a variable that we're going to use to control the loop with and assign a value to it. Okay? So within the loop, we're going to test a condition and evaluate the loop control outcome. All right, so if the loop control says you got to stay, you got to stay, okay? So that means you're going to be doing the loop again. All right, so that's basically the basic strategy for using a while loop construct. So let's say we have an actual, just like the flowchart we did, int a, and we set it to 0. So this here is set up so that your loop is going to be based on the value of a, right? Good. Let's do something else. Let's say I also have int accum equals 0. So just an accumulator, I'm going to put 0 in it. Now I'm just going to add it up as we loop. I'm going to add values to the accumulator as we loop. And so that will tell me pretty much how many times I've looped. So I could use it as a sentinel or some sort of a flag to tell me how many times I've looped. Okay? Now for the assignment, we could do the accumulator right here. So we could do this and then set the accum to 0. There you go. All right, we could do that. Okay. Now for the loop, you could do something like this: while, and then your condition here, and let me open curly brace and close curly brace. So let me just pause here for a second to explain. This is the syntax for a loop, for a while loop. So you have the keyword while, and then you have parentheses where you write the actual condition, and then within the loop of the body, you need to have some sort of a loop control. So what is my condition? As long as a still equals 0. Now, let's think about it. I've already set a to 0. That's loop priming. So that means a is actually 0. That means this is true, which forces you to go in the loop. So somewhere, you need to have some sort of a loop control so you can actually get out of this loop. Otherwise, if you don't change the value for a, you're going to remain here forever. Okay? So while this is happening, my accum here is equal to accum plus 1. So every time I loop, I am going to increment my accumulator by 1. This is just an example. Okay? That would show what this loop is for, is just to accumulate. Every time you run it, or every time you loop, the accumulator will add a 1 to its previous value. So if accum was 0, this time around accum will have 1. However, we're going to ask now the user if they want to stay or not in the loop. So now we're going to control this loop. So something like this, see out. Enter 0 to continue in this loop. else enter any other value. And here we're going to do cin A. And so the only time we're going to be in the loop if we see this message anyway, right? So let's see what happens. So right before the end of the program, let's go ahead and do an output results. And let's see, we want to output basically what's in the accumulator, just for giggles. Cout the accum value equals, and then put accum here and L and the program. So we want to see what's in it. All right, so now let's compile and run this. Okay, and you can see the condition is true, which allowed us to enter into, let me just make this here, 28 I think is good. Notice we're executing the line inside the body of the loop, which means the condition was true and we're inside the loop. Now let's suppose I put 0. Now watch what would happen. It's going to ask me again. Enter 0, so I am inside that loop. So if I keep pressing 0, what do you think is going to happen? I did not change the value for A other than reassign it as 0, right? So in other words, what's going on is that the condition is always testing out to be true. Now let's suppose we put a 1 now. Now that's going to kick me out of the loop. And sure enough, think about what was accumulated, right? So every time we got into the body of the loop, a 1 was added. That includes you trying to get out, unless you do the accumulation some other time. Okay? So notice here, the first time we came in, as we got in, the accum was 0. We added a 1 before this question was asked. Then we asked. We put a 0, which means now you go back to the beginning of the while loop and you assess and you say, is it 0? Answer is yes. Then you accumulate. So now you have 2. And then you ask the question. So by the time you're here, second line, accum is already 2. And then you have a 0 here that's going to be evaluated again when this body of the loop executes. But by now, you have a 3 for accum. So I hope this gives you a good idea how a loop actually works, right? So let's do it again. And let's run it again. This time I'm going to go straight and put a -1. But we know we executed the body of the loop at least once here. So the accumulated value is at least 1. Right, because when you got in, A was 0. The only time you changed A to some other value is while you were in the loop during the loop control. Okay, so let's do this several times. And let's say we do something like this. 0, 0, 0, 0. So you're going to stay here forever until you type something else, then you're out. Now let's make a mistake on purpose. Let's suppose you did not have a loop control, which means you never asked the user to enter a value for A other than the message here. Let's see what happens. Okay, this is going to be fun, so pay attention. So that means I am literally not allowing the loop control to do its job, right? Because really the job is done when you assign a value to A through cin. So now let's suppose I do that and just go ahead and compile and run. Watch this. So what do you see? Right, infinite loop. It has nowhere, so Control C to get out. In my case, depending on how you break a program. But you saw that it ended up being an infinite loop and it keeps running because there was no way to change the value of A to anything but 0, which means every time, it didn't matter if you were accumulating now, that has no effect on your program. What has an effect on your program is that you're never change the value for A, which means now it will print this as long as the program is running until you actually do a Control-C or Control-Z, depending on your operating system, to actually kill the process. Otherwise, you're going to end up in an infinite loop. And that was a good example of an infinite loop here. So you need to interrupt that loop somewhere right here. And that's the point here, is this here allows you to control your loop. If you want to remain in the loop, just assign 0 again to A. If you don't want to remain in the loop, give it any other value, which means you want this condition to turn to false, which means this block will not be executed if the condition is false. So remember, you have what we call priming to allow you to initially assess the condition that we need. So the 3 elements are here: priming, condition, and loop control. So you need to have these in a while loop. Fantastic. So for our next video, we're going to investigate again the while loop, and we're going to put it through a series of tests with an actual application. Okay? So this was just simply an example to show the mechanics behind it. We're going to do a little more practical example for the next video. So example 29, we're going to go back and review the while loop. We're going to do something a little more interesting other than just the concept.